All right. Good evening, and thanks for having me here in Perth. I live in a place called Brisbane, over the other side of the desert, and I haven't been to Perth for a couple of years. Great place, so thanks again. I'm going to tell you, my goal tonight is to tell you what functional programming means, just what it means. Mostly because I am sympathetic to you. If you typed into a search engine right now, what does it mean? You'll get 10 wrong answers, unfortunately. It still has a bit of mysticism around it. One of my main goals of coming here to Perth is to spend 3 days with people who would like to learn it in depth. So I think some of you are in this room. We did our monad tutorial today. Monads they have a reputation for being difficult. They're not, right? Wherever you are. It's just so that you don't write the same code over and over again. So that's done, and we'll go back to relaxing tomorrow. Okay, so I work for the Queensland Functional Programming Lab. It's a CSIRO and Queensland Government initiative. And just to briefly say what it is that I do, I try to help Australian software developers take advantage of the benefits of functional programming. That's what I do. And there's a team of 6 of us, soon to be 11. I'm hiring. If you'd like to cross the desert and come and write Haskell with me, send me an email. So that's pretty much what I do. It's quite fun writing open source code, helping out government departments who've got all their data in a mess, and they're like, help. Oh yeah, no worries, I've got Haskell. So we sort that out. I get this question quite a lot. So I don't know if you have this question, but if you do, how can I be notified about the upcoming courses? Sign up to that mailing list. Whenever I'm going to Perth or Canberra or whatever and we're going to do it, I'll write an email there. Sometimes I get this question, so these 3 days I'm burning people really hard, right? Am I right? Yeah, I'm right. I'm drilling you hard. But we're going to get to the end of it, and you're going to say to me, how do I write a web app in Haskell? Right? Or something like this. So we're doing that now. So if you're interested in that, so you've been burnt, you've learned all the introductory stuff, you're ready to go. How do I write a database, web app, whatever it is you want to do? So we're doing that this year. And yes, I do. Yes, we do. 6 of us at the moment. So just a background on how I got into functional programming. I used to work for IBM, and I used to implement this language called Java, if you ever heard of it. Basically, you got to write a compiler and it compiles your code. That was my job. And there was a company called Sun Microsystems back then. So I had to implement this thing called Java. I learnt it as much as I needed to so that I could write all the compiler and specifications and so on. And it was a simple thought that I assume everyone has had, every programmer at least has had, which is simply, surely there's a better way. Okay, so Java programmers in the room, you've all seen null pointer exceptions, and you've seen all this stuff, and you're like, do I really have to endure this? Really? And you need to develop a process to answer this question, and my process was, someone smarter than me has figured this out. Who are these smart people? And the smart people I found out were the functional programmers. They've already figured this out. They figured out how to not have null pointer exceptions, right, and so on. They've worked out how to do it. And I'm going to go and steal all their ideas. That's pretty much it. So when I first moved to Brisbane in 2003 or 4, I think there were 2 of us writing Haskell in Brisbane, and we found each other because I appeared in a television interview, and the other person said, hey, that's the person off the Haskell mailing list. He lives in Brisbane. There's 2 of us. And it kind of went from there. That's a true story. So functional programming is certainly my opinion on how to do software development. So I'm going to tell you what it means. What does it mean? Common question. So I'm going to show you a computer program. This is in any syntax, no particular language. And if we look at this procedure up here, and we notice first of all it adds 1 to the counter, some counter somewhere, and then it returns a plus b times 2. And then arbitrary code stands for the rest of the application, right? 50 billion lines of whatever it is. And then you come across this expression down here. All right, and you look at this and you go, okay, there's some code duplication right there. Can I factor that code duplication out without affecting the program? Can I do that? Did the program just change?
Yes.
It did. Yeah? It changed. Why did it change? It changed because the counter used to update twice because there were 2 calls to the wibble function or procedure. And now there's 1, so the counter only updates once. The program changed. I cannot take an expression, factor it out naively, and get the same program in this particular circumstance. And it's because of that. So if I take that out and look at this exact same program, and I say, there's some code duplication. Can I factor it out? I can. The program didn't change. That is the same program. Isn't that great? It didn't change. And that's because it is a function. Wibble, or pibble, in this case, is a function. It's a function because given the inputs, it'll return the same output and do nothing else. Okay?
Excuse me.
Sure.
For instance, you got 2 brackets, okay?
Which ones?
2 brackets.
This one here?
That,
Yeah.
Before that.
That one?
Yeah.
Yep.
Does it change the program already? It's a different command, isn't it?
Well, this is the original program. So the question I'm asking is, if I change this program into that program, did it change from the previous one into this one?
Oh, it becomes the same.
It does in this case.
Yeah.
It didn't in the other case.
No.
You agree with that? Do I have your agreement on these things? Because if so because it is the same program, or the reason it's the same program is because pibble is a function. There is no additional effect going on. Okay? So, the program didn't change in the second circumstance because there was a function, and that's because given the same output, inputs get same outputs with no other changes occurring. That is to say, we can replace an expression with its value naively and always get the same program. That is functional programming. Mic drop, see you later. I'm dead set. That is the definition of functional programming, the extent to which I can replace expressions with values without changing program behavior. That's a very simple definition. And the property of expressions when you can do this with expressions is sometimes called referential transparency. So we'd say that expression back earlier, the pibble one, that is a referentially transparent expression, whereas the wibble one was not. I cannot substitute it with its value and get the same outcome. So what? Why does the government pay me to care a lot about that? It's because of the consequences. So who uses JavaScript and Java and Python and C#, all these languages, right? You can do counter equals counter plus 1, no worries, and off you go. I can't. That's one of the consequences straight away. You can't do this, right? In whatever language it is you use, you've got an object with mutable fields in there. I can't do that, right? You can even do that. I can't do that. If I set I equal to 0, I will always equal 0. It's the end of the argument. If you come along and go I++, it will not compile. Haskell will not compile that. So hang on a minute. I equals 0, I plus plus. Contradiction. I have 2 children. When my son was 9 years old, I had the following discussion that went like this. If C plus 3 equals 7, what's C? And he said, well, it's 4. Oh yeah? Okay, well, if X times 5 equals 25, what's X? He said, well, it's 5. And I said, if I equals 0 and then I equals I plus 1, what's I? He said, that makes no sense. I said, correct. I have it on MP3 if you'd like to listen to it. That's I did not prod him at all. It's just one morning I just started saying that. So you can't do that because this expression here, I plus plus, is not referentially transparent. You cannot substitute I throughout the program and get the same program. They're all different I's. You can't do this. Common question I get, does that mean you can't do I/O? Well, of course I can. I just can't, do it messily like this. I can't just arbitrarily do it. I can't just start doing these things, right? If I replace read file with the file name with its value, I'd get a different program, right? It'd read the file once, and then that's it. Right? It would change the program outcome. If I were to substitute that expression there, read file name with its value. So the 3 days, by the way, that we're spending is I've taken away all these tools from 30 people in the room who are so used to like read file, write file, I++, everything's just fine. And I've just taken all of that away from them. And they're standing there naked, like, how do I solve all these problems now? And I substitute in new problem-solving tools. And it causes some pain, but that's okay. It is okay, right? It's a little bit of pain. Yeah, not too much. I'll give you an example. Well, these are some of the questions that we will immediately ask once I take away all your tools. We'll be answering that third question tomorrow, by the way. How do we design our data structures? I can't have mutable fields anymore. What do I do? How do I write loops? How do I even sum the values of a list? All right. So if you've never heard of functional programming, how do you sum the values in a list? How do you do it?
MapReduce.
Oh, you've heard of functional programming. You go x equals 0. For each element in the list, x equals x plus the element. Return x. Am I right? Something like this. If I remember rightly, the last time I wrote a for loop, it's something like that. So set a counter at 0, or a start position at 0, go through the list. For each element, add the counter to that element, return the counter. It's the sum of the list. But there's a different way of thinking about this problem. So this is an example of, I'm going to take away this. I've taken away loops, they don't exist. And we're going to sum up the elements of a list. And I did hear someone say recursion, and that's how we're going to do it. So these things are disallowed, okay? If I set r equal to 0, what's r? It's 0, end of argument. So this thing here is not a thing. If I set I equal to 0, it's 0. That would be a very uninteresting program. R equals 0, I equals 0, the end. So there's another way of looking at the problem of adding up the integers of a list. And it's this. If the list is empty, return 0. But if it's not, then return the first element plus the sum of the rest of the list. Does everyone agree that that adds up all the integers in a list? So basically we have a list, and a list can be split into two possible cases. Is it empty, or does it have a first element and the rest of the list? And that's the definition of a list in Haskell. In fact, I could show you the code. I don't have it there, but I could show you. It's just basically is empty or has the start element and then the rest of the list. That's the definition of the data type. So stepping through that definition, let's add up a list. And we say, well, is that list 6597113, is it empty? No. well then the sum of it is 6 plus the sum of the rest. And so on until we get down to the sum of the empty list, and we say, well, is it empty? Yes. And then we substitute 0. And then add, and then the sum of all of that is 94. And at no time did I say I equals 0, oh wait, no it doesn't, it's I equals I plus 1. There's the Haskell code. Who's not a programmer? Can you read that? Just curious. I'll explain it to you and then you answer for me, alright? So the sum of an empty list is equals 0. The sum of a list that has the first element and the rest is the first element plus the sum of the rest. I think that's pretty straightforward. Who's not a programmer and can read that? I struggle myself. I is 0. Oh wait, no it's not. Hang on. That's how I read that code. A common criticism of functional programming is that it's unintuitive. I'm kind of mocking that criticism. Lies. My 9-year-old disagrees. So yeah, this is a good question, a much more serious question, which is why would I even care? All right, you might be over there writing your loops and you're like, I'm totally cool with loops. I'm summing up the list. Everything's just fine. Leave me alone. All right, but I'm saying, but there's practical benefits. What are they? And this is quite a deep question. I'm happy to answer it for days and days and days if you like, but I don't have that much. But I'll do my best in a short amount of time. So they're not obvious, and the people who are in this 3-day course, it's still not obvious, I think. So we're up to day 2. It's still not obvious. But just to give a hand-wavy overview, right? So, and there's a penalty. The penalty is I've taken away all your familiar tools. So you're trusting me right now, and I completely appreciate that. I've taken away all the good things, and I've not yet given you any. Or I've not given you anything good to substitute them all back. But I can reason about programs, okay? So this is a hand-wavy thing. I could concrete this in if I had the time. But basically, looking at the definition of sum in Haskell, let's go back and have a look at that actually. The sum, so for example, if I look at this program, I can reason about, for example, that line independently of that line. They're 2 discrete programs, and they exist independently, and I've just put them together to make a new one. Not only that, to do this one, I've taken the plus function and that value and that function and made a new one. And did the sum function delete the database? No, it can't. Now you might go, well, that's insane. Some functions don't delete databases. And I would say, yes, they do. You've surely worked on this project where the sum function deleted the database. Right? Anyone who's been doing programming long enough goes, who put that there? That's insane. It updates the fling and flop and whatever it is, right? We know these programs. They exist. They can't exist here. They are discrete units. It's usually like not deleting the database. It's like inserting a database row. Oh wait, now there's 2 of them. Whoops. Something like this happens, or updates the XML configuration file, whatever. I don't know. Can't exist here. These are discrete units, and I can reason about them independently. Not there, I can't. I equals 0. Oh wait, no, it doesn't, and so on. I have to do the whole thing all at once. I can't reason about that discretely. The plus function I can, and I mean plus function I can, because it's a function. The things that are not functions I can't. So, whoops. So, the other one is composition. So it's basically, if I have discrete units of programs, I can glue them together to make slightly less smaller units. And I can keep going. So, and by that I mean, they're discrete. I take another discrete unit, glue it together. I have another small unit, and then I can take another one, and so on. as opposed to the monolith program. So who's got a monolith program at work? Just by the way, just come on, let's be a bit honest. So everyone's got one, right? There's the monolith program expert on your team. Yeah? You're like, hey, you know, the project manager wants to add a widget in the corner, and you go, what happens when I go and twiddle the code this way and add the widget? You go and ask the expert, and he's like, oh yeah, it'll take 6 months, whatever. And you, no? Oh, that's true, yes. It's like, oh, what, you want to add a widget? No way, we can't do that. Oh, it'll be a rewrite. Yeah, that's really what happens. That's because, or at least I'm trying to claim that the program is not in discrete units of composition. It's just a monolith. A depends on B, on C, on D, and then back again around A, and so on. And the expert tries to hold it all in their head. I've never met an expert that actually can, but they try, and good on them. But it's so difficult that you hit a scalability problem with your development, and that's the size of your program forever, and that's why they say no. You're not adding the widget. And I'll be honest, I've worked on monoliths, don't worry. I've written them myself. So, it takes a lot of work, okay? Those of you who are up to day 2, good on you. All right, I have set you on fire many times, and I understand this. I'm a little bit sorry, but not a lot, because there's benefits. All right. So for those of you who are not there, you know, I am hurting people a lot. We have completed. There's a course called the CIS 194 Undergraduate Introduction to Haskell at the University of Pennsylvania. It's online. You can go and do that right now. And we've just done that in 2 days. All right, so that's how hard I'm hurting people, because it's a lot of work. So what I'm getting at is if you were to ever commit to taking advantage of these things in your programming, you would have to do a lot of work. Make no mistake about it. But I'm committed to helping you. That's what I want to do. All right, so I will hold your hand when you fall. I will pick you up, and we'll keep going and through the trenches, and we'll get to the other end, and you'll be like, aha, I know what a monad means, and now I can take advantage of these things. That's my job. That's my goal. And join me. Thank you for listening.
Thank you so much, Tony.
Cool.
I'm afraid Lee has had to run off, so I'm Rebecca, and I'll just finish up for tonight. I imagine that Tony is happy to take a couple of questions.
Absolutely.
And possibly our other speakers are as well, but maybe what we should do instead is in a bit of a pat down and maybe moving across to something like Cheeky Sparrow, that might be a good opportunity for a lot of questions to happen. So perhaps we could just ask like 1 or 2 if anybody has something that they would particularly like to ask Tony, and then if our other speakers would like to join us later or as pat down, maybe you could swap some details with them. Does that sound okay? Yep, and that way we can wrap it up, because I know it has been quite a long night. Is there any questions that,
Yep.
Why should I use Haskell rather than do programming in a functional style in a more normal language?
Mm-hmm. Good question. I get it. I get it. So I strongly encourage you to try it. And I have tried it. I could show you the code. I've done it in Java, C# and Python and JavaScript. And Scala, yeah, forget that. If you do try it, you'll have additional problems, right? So I would argue that certainly in an educational environment, it's already hard enough. But suppose you're over that. You're like, yep, I've got this covered. I'm going to go and use JavaScript or something. And the problem is you'll start hitting JavaScript problems, right? So for example, that sum function that I showed you before, if you go and write that in JavaScript right now, I'm going to give it a list with 10,000 elements. It'll build up a stack of 10,000 and then bang, Stack Overflow. Okay, so that's not to say stop right there, don't do anything and go back to what you were doing before. It's that you then have to recognise those penalties exist. So you can't just naively write a sum function anymore. You have to be aware of JavaScript's limitations. And this is pretty much true for many other of those languages. But I do encourage you to try and get the Stack Overflow and go, oh, what do I do now? Yeah. And in fact, one of the open source projects on my team is to help you overcome that. So for Python and soon to be JavaScript, right? Which is basically, I have this problem, which is I could convince you that functional programming is the bee's knees right now, and you were completely convinced, but you've got a million lines of Python back at work, or JavaScript or whatever, and there's nothing I can do that can just say, well, just stop work right now, throw all that code away, and let's start again, because that's imposing quite a big penalty, and I want to try and make that penalty small, even 0. Yeah.
Can I do a brief announcement about something?
Yes.
Yeah, thank you. I just wanted to say thanks so much for DDD Perth for organising this event tonight. It's been awesome. I've been to the main conference before and it was fabulous, right? I'm actually here from the IT Professionals Association. I've invited the members of our group to come along tonight and experience DDD and hopefully help us go through our journey of representing more than just one kind of IT professional, because we started out as a group for system administrators. We have got a broader perspective now. We're more about representing technical professionals. If anyone is more into policy or management, then the ACS is probably a better organisation. But if you want a group that could help you look for a job, help you upskill to get a better job, or help you in negotiations with your employer, as well as just help you get a sense of friendship from other IT people that you can go to meetings with, then speak to me afterwards and ask me about the ITPA. Thank you.
Thank you.
My name's Alistair, by the way.
So, look, thank you everyone for coming down to this, our first DDD by Night event. We have announced our conference date. It is the 4th of August. We have opened our ticket sales yesterday, and we have opened our call for presentations yesterday as well. Tonight we had 3 very different talks, very entertaining talks as well, and I wanted to say thank you once again to our 3 speakers for such a wonderful, representation of the breadth of talks that you can expect to see at a DDD Perth event. If you are at all interested in learning more about DDD Perth, then speak to someone in a green shirt. And I highly encourage you to come up and say thank you to each one of our 3 speakers, and especially if you would like to learn some more about their talks tonight, please connect with them one-on-one. As we pack down, I also had 2 other things to say. First of all, you'll notice these great orange banners here. Bank West, where we are today, are such a fantastic supporter of the software community, and we wouldn't be doing today's event without them. So thank you once again to Bank West for such a fantastic venue and support. We have also just announced our platinum sponsor for DDD Perth. Have we, Ian? No, you're looking surprised.
Go ahead.
And so actually Remo comes from DDW, who are our platinum sponsors, and that's, for the entire year of DDD Perth. We also have a platinum sponsor, so we just wanted to shout out and say thank you very much to them as well. I think that's really it for us. Thank you once again for coming on down, and I hope you've had a nice evening.